Good morning, this is Dr. Turner for Integrated Math 2. Today we're going to be covering section 3.2, which is looking at quadratic functions. As I mentioned before, basically the rest of unit 3, 4, 5, we're going to be looking at different parts of quadratic functions, breaking them apart, looking at each of the different forms, how to convert the forms, how to graph the forms. So a lot of this is going to kind of blend together over the next few weeks. So just keep that in mind. So in 3.2, we're specifically looking at quadratic functions that are in standard form. And if you remember from 3.1, we have y equals ax squared plus bx plus c. So this is our standard form. Because we're doing this online right now, there are just simply a few questions that will ask you to graph in standard form and identify the key features. So if we're using Desmos together, I might give you something like y equals x squared minus 6x plus 5. So you'll just type that into Desmos, and the nice thing about Desmos, and I'm going to change the contrast here real quick. The nice thing about Desmos is that when you put in the function, it's going to automatically identify what are known as the key features. So if you look here at all these points, I have my y-intercept. I have my zeros or my x-intercepts, and then I have the vertex. So all those key points are being highlighted for me. For your assignment, there are a couple questions that I'm asking you to just simply do this. Type it into Desmos, identify what those key features are. So you click on them, it'll tell you the actual coordinate, like 0, 5 here or 1, 0. Take a screenshot and submit. Now this is using Desmos, obviously. Well, if we were in person, we wouldn't be using Desmos. We'd be doing this by hand. So the goal then is, if we were doing this by hand, well, how do you graph a parabola? This is a little different than graphing a linear function. The linear function, if I tell you the y-intercept, I give you another point, you go up and over, you can draw the straight line. Graphing a parabola by hand is a little more complicated, but if you can identify the key features like the y-intercept, the x-intercepts, the vertex, then you can get a sketch going. And that's really all you're asked to do if you're asked to do quadratic functions, is to sketch. It doesn't need to be perfect. So the question then becomes, well, how do I identify those key features? We talked about this in 3.1, right, where if it's in standard form, we already have the y-intercept, whatever that value is by itself without a variable. That's your y-intercept. So that's one point that can help me sketch this graph. The other thing that we want to be able to do here in standard form is to be able to identify the axis of symmetry, which is that line that's dividing my parabola in half, and to identify the y-intercept. So if you're doing this online, you could just be typing it in like I'm doing now. Right, typing it into Desmos, that'll tell you the vertex, but the goal here is to be able to do it algebraically, to do it without Desmos. So how do we do that? We talked about this in 3.1. To find the axis of symmetry, that formula is x equals negative b over 2a, where b is the coefficient of your linear term, so it's what's ever in front of the x, and then your a is the coefficient of your quadratic term, whatever's in front of the x squared. So to figure out the axis of symmetry here, I'm just plugging in the values. Negative, my b here is negative 6. Remember to take the signs. Over 2 times a, which is 1. Remember that if you don't have a coefficient shown, that there's an invisible 1 there, right? So that's my a term here. So negative 6 over 2 times 1, negative in front. I end up with x equals 3. And if I graph this, then indeed, that is my axis of symmetry. It's the line that's dividing it in half. We talked about this, we talked about this in 3.1, but remember that the vertex will always be along that axis of symmetry. That point has to be, by definition, on that line. So we already know that our vertex is going to be 3 comma some point. And yes, if we're using Desmos, we can see that what it's supposed to be. To do this algebraically, we're going to take the 3 now, and we're going to plug it into our quadratic equation. So I end up with 3 squared minus 6 times 3 plus 5. And if you're using a graphing utility or a calculator, it's going to calculate it for you as here. So I get -4, which means my vertex then is 3 comma -4. If I'm using the computer, I can verify that using Desmos, and yes, my vertex is 3 -4. So those are the 3 things I'm asking you to do in this section. One is graph using Desmos and identify the key features. Point 2 is to identify the axis of symmetry using this formula here. And point 3, tell me the vertex, which is also using the axis of symmetry formula. And then whatever we get for X, we're plugging in for Y to solve. If you guys have questions, please reach out to me. Otherwise, have a good day, and I'll talk to you soon.